Okay, so let's have a look at an example program using a procedure. So this is a very simple program in JustBasic. We're declaring a variable here, calling it x. We're creating a loop that will repeat from 1 through to 10 in steps of 1, and each time in the loop we issue a call to a procedure called calculate square, and we give it a value to work with. In this case it's x. So each time this loop goes round, x will change and it will proceed through the values 1 through to 10. So this is the procedure code down here, and we can see that the code starts with a declaration that this is a sub. This is the name of it, it's calculate square, and it takes in one parameter, x. This x doesn't have to be the same name as this one here, and in actual fact this is a local variable that is declared specifically for this function. Just happen to call it the same name just to keep things simple. Changing the name won't affect the operation. Any changes to x in this local function doesn't change the value of x in this function up here, and you'll see that as we go through the program. So the program will print out the square of whatever x is, so the square of 1 is, the square of 2 is, etc. We then calculate x squared by multiplying it by itself and storing it over the top of itself, and then print out the value of x. So the square of 1 will be 1 times 1, the square of 2 will be 2 times 2, which will be 4. So you'll see that the local value of x will actually change, and you'll see that in the output of the program. However, the looping value here of x just remains 1 to 10, and that illustrates that the variables are in fact in separate memory locations. They aren't one and the same. So if I run that program, you can see that it loops through 10 times. Square of 1 is 1, square of 2 is 2, square of 3 is 3, right the way through to the square of 10 is 100. So that's a simple procedure called on the back of a function to make it very usable. We could have another example, and another example I'm going to use is to print out a simple version of a times table. So if you just bear with me while I copy that code. So this program has a loop just to allow me to go around and do another times table. We may have used this example in a previous session. So if I print out times table for 5, then it does that, fair enough, and we can exit. So that's fine. That works as it is. Now if we write the same program but using a sub procedure, then what we can do is take out some of the code that does some of the calculation into a sub procedure. For some reason that hasn't worked. If you just bear with me again while I try and copy the appropriate bit. So we now have a sub-procedure called timetable, and we give it a value which we'll call locally timetable. So I can take out that statement from up there and replace it with a call to timetable and pass across my value of count. So that will work in exactly the same way. I'll remove my loop. So I want to pass across iTable. The loop has been removed to within the sub-procedure here. So we've simplified our main program, and we've taken away a lot of the code that was used for creating the actual loop outside. So if we run that program, then we can output that. That's fine. You can see we've got an extra line of code there. We'll take that out, and that works. That line of code was duplicated in the actual sub-procedure, so we don't need it up the top. So that's fine, and we can see that program works exactly as it did previously. The sub-procedure simply has removed that piece of code. Now the neat thing is that once we've done that, we can actually use that call several times. So we could say I'm going to print out the times table for a value either side of the value that is entered by the user. So the value of I table minus 1, the value of I table, and the value of I table plus 1, and that will then output the 4 times table first, the 5 times table, and then the 6 times table. So we haven't had to write the same bit of code 3 times and adjust the values. All I've done is make 3 calls to the function, the procedure that does the hard work for us. So that shows you how we can reuse some code. So you might want to have a look at that example in detail, follow it through, and see how it works. Just for now, what I'll do, I'm going to go back to the previous example and show you in a bit more detail by using the debugging facilities how it actually works. So just remind ourselves what this program does. It's the square calculation program. So we'll step through this program using debugging. So we can see our output on the left here, and we'll step in and we can watch the value of x. So x is 1. We're then going to call our calculate square function, and we can see that we've got x is 1, x is still 1. We're going to output x n sub, and then you can see how the n sub jumps back to next x. We can then increment the value of x to 2, jump across to the sub procedure, and we can then print the square of 2 is 4, and that will jump back to next x. So you can see how that code is jumping around. We're jumping down to the sub procedure, back to the loop, down to the sub procedure, back to the loop, down to the sub procedure, back to the loop. Okay, so you can get the idea of what's going on. What I'll actually do, just to make that a little bit clearer, so you can see the names of the variables, is I'll change the name of the variable in this local procedure to be y rather than x, and then you can actually see how those different values are calculated. So we can jump through, we can see that it's showing us x as the variables that are local to the part of the code that we're currently working in, and then as we jump to our sub procedure, we've lost sight of the variables which are local to the main procedure, and we can only see our local ones, which are now called y rather than x, to avoid the confusion. Then we jump back to the sub procedure and we get sight of the local variables for that piece of code. Okay, so you might want to type that example in, step through it, and see what's going on for yourself.